Hi everyone, this is Fred Briggs, and here we are for session 2 of the CAD PCB tutorial. So in session 1, just to show where we left off, we had created a schematic, and then we went up here, we clicked on this button, and it generates the board view. So this is where we're going to start off today. We've generated all of the parts, we've run all of the wires on the schematic, so now we actually have to design the board. So first thing we're going to do is click on the move button and take a look at all of our parts, and you can see it's got a bunch of yellow wires that follow everything around. So these wires are actually representing where we need to put all of our traces. So when we're completely done here, we shouldn't see any air wires. The yellow wires are called air wires. We shouldn't see any of these air wires left. So to get started, first thing, this white line we see around here, this is the outer dimensions of our PC board, and you can see this is quite large relative to all the parts. We can fit all of our parts on here with plenty of room to spare, and we don't want to have that much room left. So we're going to go in here and go up to the white line, just hit escape. Go to the I, which is information, click on those white lines, and it'll show us what they are. So we're using inches right now, our imperial system. I typically change this over to metric, which we'll do in just 1 second. But these are giving the dimensions of this board. So if we want to shrink this down, let's just make it, I don't know, 3 inches by 2 inches, just to give some round numbers here. And then click OK. And if we want to know what layer this is or what it's being done, you see it says layer 20 dimension, and we can make these anything. So for right now we're going to leave that alone, and we'll talk about layers here a little bit more as we go along. So we just changed that one line, so now we've got funky shape here. So let's go ahead and click on these others and make sure they all match. So change that to 3, and now we've got a nice setup to work with. So this should give us enough room to play with. So we're going to start off by putting, this is our 328p. You can see Atmel 328p microcontroller. And we've got our crystal right here. Now, we want to get these lines lined up as best we can. See how here our lines are crisscrossing? That's not really going to be an ideal situation when we go to route these things. And similarly, if we have, say, this part over here, and there's all kinds of lines that crisscross every which way, that's going to make life a little bit harder as we go along. So we're going to want to get these to line up as best we can here. So, and you notice in order to get things line up, when I'm going, you see there's a white cross on here. I left click on that, and when I do that, I can actually get this to move when I click on that white cross. And then if I want to switch orientations, I can just right click on the mouse and it'll change the orientation here. So if I have it like this, you can see the wires are crisscross. I flip it over and bang, that lines up much better. All right. The other thing to consider here is when we're fabricating the board, we don't want to get these right on the edge here, right bumped up like this. That's pretty close to the edge of the board. We're going to want a little bit of room when they fabricate these things. They're going to route or sometimes crack the board from the next board, and if we have it too close, it can sometimes cause some issues. So we want to keep a little bit of a border all the way around this thing. But in this case, we've got plenty of room, so we're just going to move that up. And again, we'll uncross these and give a little bit of room there. So and then we can start picking off our parts here, and you can start to see where these things actually go to. Now, I'll show you a little trick here. So some of these parts, for example, when I get close to it, you can see GND or ground is what this line is going to. And ground, we haven't really defined a ground plane, so it's trying to run that wire to another individual ground. So this isn't really a wire that we're going to route, and I'll show you how that works later. We're going to end up doing a copper pour. So let's add add a little bit of room here. So this long row here, this is just a row of breaking out lines on the microcontroller. So you see how they're all twisted up. So we may go back into the schematic a little bit and tweak some of these lines and change the order in which they're routed here to make this line up just a little bit easier for us. And then this one with 6 pins, this was our FTDI line, which is also going to serve as a way to power the board. Again, this is a really simple board, and for most people this is going to be a little bit too simplistic, but ultimately it is a functional Arduino board which you could operate as a Uno. So this is our other 22PF cap, which is going to come off of our crystal. This is a resistor for the reset line, which we'll just tuck right in there. And then we've got a capacitor which ends up getting used on the for resetting the reset line to load firmware on there, to load a sketch. Alright, so that looks like a pretty reasonable layout. Now to fix some of these lines, like these grounds, we can actually come in here and click Rat's Nest. That'll actually clean up some of the lines, and it'll take those ground lines to the most direct, the closest one. But ultimately these are all going to go away when we put a copper pour in here. So now that we've got things kind of sort of arranged how we think we're going to like, and we've put a little bit of spacing in between everything, we can go ahead and start to route this thing a little bit. And with the crystal, we don't want to have this thing way off. We want to keep this relatively close to our pins here. So we're going to click on the route, and this is actually going to start routing. And before I do that, we're going to go to View, Grid. We're going to change this to millimeters. I like metric, and I usually set it for 1/2 millimeter. That gives me a little bit finer control on things. So what we're doing here is we're setting the grid. So if I change that, see, I can move this really fine. Whereas if I change View Grid and say change this to 2 millimeters, the smallest movement I could make on this is 2 millimeters. See, when I move it now, it's these big jumps between positions, and I like to have a little bit finer control over this. So around 1/2 millimeter is usually appropriate. So let's go and start routing this. So again, click on the route button, left click, and then you can just take the click on something and you can see that a line comes up. Now we've got 2 layers here. We're doing a 2-layer board. Blue lines represent the bottom layer, and we can change this to red, which would represent a top layer. And you can see this is coming out at 90, these corners are 90 degrees, and that may not be ideal for what we're trying to do. And if I want to change that, I can click up here to different types. So now you see it comes out at a nice 45-degree angle, or I can get some other ways of getting the line to come out, or I can just have it straight and come out at whatever weird angle I want. So the easy way to change these instead of coming up here and clicking these is actually right click. And you see as I right click, you'll see the toggle through the different types. I like this type, usually works well for me, and in this case we just want to make a straight line down, so I bring it over to this and just click, and boom, we have now routed that line. And for the other one, I'm going to just stay with that that line, bring it over there, and we're just going to stay on the top layer. Now one thing to note is we're using a 0.4 millimeter width trace, and for low voltage lines like what we're doing right now, that's just fine. But as you get into stuff that has more current or different voltages, you may want to adjust this, and there's calculators online for figuring out what's appropriate. And for everything we're doing here, 0.4 should be more than enough. So I'll get these all routed. So now you notice I'm not doing these ground ones. There's no point, and I'll show you why. So if I start a line and don't want to use it, I can just hit escape and that will disappear. And let's say one of these lines up here I did, but I'm not happy with how I did it. I can actually click on rip up and pull that line away. And if I click on that line multiple times, I can get the whole thing to go away. So let's go ahead back to route and let's put this all back together. Okay. And you can actually see if you look close, there's a little bit of goof up in there, routed around, so we'll actually just rip that up, reroute that, make that a little cleaner. Okay. Now let's start putting in, this was the resistor pull-up line for reset. Now, one thing we don't want to do when we're routing these lines is we have to make sure that we're not touching other lines, and I'll show you an example. So we need to route this line over. If I did something like this, it clicks over and it looks like it worked, right? However, this line here crossed over this via. These green circles are vias, or your through holes, right? So these go all the way from top to bottom. So we cannot go through the middle of these things. And if we do this, we now just connected this one to this one. And later on in the third session, I'm going to show you how to run some error checks to make sure that you didn't inadvertently do some of that. But for now, just be aware that that is a mistake. It will throw errors and it will make it so your board doesn't work. So let's just go back to route and all right. Now RTS, and we're keeping this pretty simple here. We're doing this all on the upper level, on the top level with red. So, but now we've got a problem. Now if I try and route this, I'm going to cross a line here or here. I suppose I could go down here, but it's getting pretty close to the edge of the board if I wanted to route down here. And although that's going to work, it's probably, there's a possibility that during fabrication, because it's so close to the board, it may cause some problems. So we have some other options here. So if we go back to route, we can change this to the bottom layer and actually run our traces on the bottom. And since we're on a different layer, we can actually crisscross the red without any problem at all. So let's just go ahead and run our bottom layers there, our bottom traces, and we can cross over the red without any problem. Alright, so now that we've got these done, let's take a look at how we can do something a little more complicated. And actually I'm going to rip this trace up so I can show you some things here. So this one, let's go ahead for this is I'm sorry, that's ground, so we're not going to do that. So we'll go ahead and put this back. But I am going to show you how to do a route with a via. And actually up here, since there's lots of lines to crisscross, let's go ahead and do that. So let's start back with our top lines, our top layer, and pull this up here. And quickly, we're going to run into problems here. So I can run this next one on the bottom layer, and that'll work. Well, whoops. But I can run this next one. I can run it up top and this will work, right? But quickly we're going to run out of options for doing things like this. So how are we going to get this? Well, I can't go that way. That's getting pretty close to the top. So what are some alternatives here? So let's actually move this trace out of the way, and let's move it a little further this way. I'll show you how we can change layers. So we can do for this one is we can come across, come into this, cross the blue one, but we can't get across the red one. So what I can do is just left click there, wherever I would like to terminate it, come up, click bottom, and it'll automatically change over to blue, and now I can change to blue, and then then click it again, click over to top layer, and now I've just crossed both of those successfully. And then I can bring that trace around, and these squares here are actually now vias. So this was a way to actually cross multiple things. This wasn't the most elegant way to do this, but it is a way to show you how you can use vias to navigate. So again, left click, bottom, but again I get stuck, so I'm going to hit back to top, and then back to bottom, and I can do that as many times as I have to traverse all of the different layers. Right? So, and for this one I'm actually just going to come around the top. Alright. So now we've got these two lines, which actually need to come all the way down over here. So we're actually going to need to take these. Well, I can't come through here. I might kind of be able to sneak them in between, but that's getting pretty close. And during manufacturing, if you were to have something that was this close, it may or may not manufacture correctly. And we'll talk about those tolerances a little bit more in the next video. And having things that close are liable to throw errors and ultimately just not get manufactured correctly. So we want to avoid being that tight in. So we have a couple options. We could actually change the width of the trace down to 2.254, put a smaller trace, and that would give us a little bit more wiggle room in between, right? But it's still awfully close, and ultimately might have errors during manufacturing. So again, just hit escape to stop that, and I'm going to hit rip up and just click on this to get rid of that. So I think what I'm going to do is just come around the side here. And again, these are so I came pretty close down right here, right? This is probably not too bad, but it's a little closer than I really intended. So once traces are in place, you can actually click on them and actually move them around a little bit. So let's just move that a little bit further away from those vias for those capacitors. All right, and then we can do the same thing, go back to routing, and we'll just follow the same path here. Oh, we get stuck though again, right? And so we have our options to cross over. But instead of crossing over, let's just go ahead and hit escape. Let's rip this up and just use the top layer, and then we can just cross over up here. Click on it, change over to the lower level, and then finish it, right? Well, we just created a little bit of a problem for ourselves here, getting across to all of these. So actually, I think I may move these over to the top here. But before I do, I think you get the idea on how you would route something like this. So what I would like to do next is actually put a copper pour in here so we actually have a proper ground plane. So what we do is click on Polygon, go up to our top corner, left click, and it's going to give us a 90 here automatically. And then I go to the opposing corner, left click, and then bring it up. I'm going to zoom in using my mouse and then click on it. And it's going to turn to a dashed line, which is exactly what we want. If it does not turn to a dashed line, then you have not connected this properly, and you're going to want to redo that. And then we're going to want to do the same thing with top. So we click onto the top layer, and it's going to give us a 90. So we go to the opposing corner. Again, I'm just using the mouse wheel to zoom in and out. And come up and we want to zoom in and put this right on it. Boom, we've got a red dashed line as well. And then we can type in name up top here, hit enter, and then go click on one of our dashed lines, and then I'm going to type in GND for ground. And this is going to be our copper pour, and then same thing with the blue one, GND. And I've just named both of these, and this becomes our copper pour. So to see what that actually looks like, we're going to click on Rat's Nest, and as soon as I click on that, this whole board is going to fill in all of these spaces and connect all of our grounds to that. So let's see what happens here. Wow, there we go. So anything that was named ground automatically connected, and here's an example of that. So pin number 8 was our ground, and you can see it put a cross in there. And the reason for the cross is because if you put the copper touching all the sides, it can become hard to solder to that because it's going to wick away the heat in the copper plane really, really quickly. That's why they do that. But that is an option, and you can adjust these settings. And you can see it again did it on these VIAs. So, but you can see we've still got some yellow here, and these need to continue to get routed here. So we're going to go ahead and route. This is our 5-volt line, which we haven't run to our microcontroller yet. So let's go ahead and click on the red. Oops. So we'll click on 5 volts, and I'm going to go back to that 0.4 trace width. And we'll run this right through the middle. There's no problems running this through the middle, but what the heck? What just happened to our run, right? Well, if I hit Rat's Nest again, it'll update the program and show that. And, oh, but there's 2 different 5 volts, so we need to actually connect both of these. And we'll just run that up there, hit Rat's Nest. There we go. So we just need to go ahead and finish connecting out all of these lines up here. And I think so we're going to make that just a little bit easier, I'm going to move this line up so we have space to do some vias in between here, and then we'll run everything out. So let's do that real quick. So again, let's start on the top. And where's this one going? Okay. And if you could actually come up to these these vias with the click on the eye, click on this, double click on it, and you can actually change the shape to round or square. I personally prefer the round ones, and then redo the rat's nest, and I'll show what you get there. You do have to keep a little bit of spacing between the vias and any of your traces to make sure there aren't any kind of production problems. And let's get this routed as well. We're on the, let's go back to the top layer. Again, back to the top. And we're going to need to get across this one here. So let's go back to the top. And it's going to start to get just a little bit tighter. And this is why when we put this row of header pins up, we put them a little further away, right? So again, let's go back to the top here. We'll actually run this one. Let's do this one. So we're actually going to hit escape. We're going to unroute that to rat's nest. Oh, we didn't delete all of that. Delete. Alright, so we're actually going to take this, create a little bit of spacing down here, and let's run stuff out this way. And to the bottom, and then back to the top. And we're going to keep this in somewhat tight so we keep room for the other two that we have to run. Again, hit rat's nest to show what you've done, and then we've just got one final route to do here. So we'll just get this last one routed, which we'll just bring up on the top layer here. Oops. Let's start that one over here. And we'll just drop it right in there. Change it to bottom to put a via. Just bring it across. And there we go. Now that via is awfully close. So we're going to take the move, and we can just sort of shift that over a little bit. Now we've got 0.5. Well, let's change that to 0.25 millimeters. So we can get a little bit finer control of how we move this. So let's get just moved over a little bit. Hit rat's nest, and there we go. So we've got a fully routed board with all of our components on it. So we have an Arduino, we have a crystal, the 22 picofarad capacitors, we have a 6-pin for our FTDI, and we have a resistor pull-up on the reset line. So really about the most basic Arduino you could set up. So, but this doesn't really show us what all of these pins are. When we go to manufacture this, we wouldn't know what any of these pins are. We'd have to, reference our schematic and diagrams, and that would be a pain, right? When you go look at an Arduino, there's white writing or silkscreen on this, and we'd like to do the same so that we know what everything is when we go to it. So we can click on the T for text, and let's identify what some of these pins are. So let's write G and D for ground and put that in. But what the heck, it's blue. That's not quite right. Well, that's because it's automatic. That's what layer we left it on. So we need to tell it to go to the silkscreen layer and that we're trying to put white text onto this. So in this case, we're using 21 or T place or top place. Or if you wanted to put it on the bottom, you could use 22 and B place. So let's use 21 and T place. And again, I can just right click on this to turn it any which way I want. So I'm going to go ahead and put this right next to our ground, just left click and drop it right there. And you can see that's our ground. So now when you solder in your header pins, it's going to show where your silkscreen is. So we can go, but that G and D looks pretty big. So let's go ahead and click on I and then click on the little crosshairs next to it. And then we can adjust the scale here. So they're doing this. We could change this from 1.778 to say 1.27. Get this a little bit more reasonably sized. And get that lined up. So we can do that for right now, just to show you one more function, I'm just going to click copy and then move that over. Now you can put this over traces. You can also write it over vias, but depending on how you did the via, and in our case how we did the via, all of these green dots, if you were to put it over like this, it would get, you wouldn't see most of it. Anywhere that green is or those black spaces, it would all be wiped out. You would just see a little bit of the G and a little bit of the D. So that's not going to be an acceptable way to do this. You would need to put it to the side. So, but now I've got one extra on there. So what do we do with that? So you can actually come over, hit the delete or trash can, and bang, away it goes. So we'll just come back to move, get these lined up. But they're all labeled wrong now, right? So now we can again come in with the I pin and change these to the name. So we named this one TX. So let's go ahead and click on information in the lower section here, just change it to TX. This one is RX. This one is RTS. This one is our 5-volt input. And although we didn't label it, this one is CTS. And you could either just not bother labeling it, or doesn't matter. So you would go around and do this exact to all of the rest of them, and if you wanted to keep consistent, you could click on this with the copy button and bring it up here. Again, it's upside down, so we would right click to get it to the direction that you think is appropriate, and then you could name all of your pins. And it's good practice to come through and actually name all of these and say pin 5 or 7 or whatever it would line up to the normal Arduino thing. We're not going to do that for right now. So that leaves us with a complete routed board with silkscreen on it. So please join me for the next installation, where we're going to talk a little bit more about layers, doing design checks to make sure we didn't make any mistakes either on the schematic or on the routing of this board, and then create the Gerber files, which would be all of the different layered files that you would send to a board house like OshPark, which is what I'm going to use for an example. So thanks again for listening. Let me know if you have any questions in the comments, and please subscribe. Thanks.